Thank you very much for bearing with me. Sorry, we got a little late, but I appreciate your patience. And also, I want to give big thanks to the organizer giving me this opportunity to present. I'm a big fan of PyData conference and the local meetups as well that happen often, like all over the world. The London one is really nice, and there are other ones in Cornwall and other places. So you should all come to those meetups. And but yeah, today we're going to talk about time series forecasting. We're going to use a simple example of weather data, but this thing can be applied to any kind of time series data. Just to get an idea, how many people are familiar with time series data? Okay, wonderful, majority of the crowd. For those who are not, I'll give a little overview of what that is. While I'm doing so, I'll also talk about time series database. Then we're gonna look into time series machine learning based time series analysis. And then we're gonna get to the coding part when you should have your laptops ready. It's gonna be pretty straightforward. Everything is on GitHub. And and any questions, anytime, just raise your hand. I like to keep it interactive because it's a lot of things we're gonna cover today. So we already covered this. There are two main things when we talk about time series analysis or machine learning for time series: forecasting and anomaly detection. We're going to talk about how we can do this in a database, coding, and Q&A anytime. I don't know if there is a floating mic for the thing, but I can repeat your question if you ask anything. So what is this? Can anybody? Well, I guess it's probably most of you already know, so I'll just answer that. It's a data showing time series information. One of the chart is showing how the web page loads and all the assets, at different interval, how long does it take? Observability, right, for your web application. Another way to visualize the same, this is, for example, an IoT data in a different tool instead of in a web browser. We're looking at in a tool called Grafana, very popular for visualizing time series data. So, point I'm trying to make for those who are new, time series data is really everywhere. It's the type of data that has a timestamp associated with it, and the timestamp is a critical feature of the data, because you are doing like any kind of query. You want to know like how long certain element on the web page took to load. Or you are looking at, let's say, sensor data from IoT. Let's say this building we are monitoring, in real time, like all the sensors, the HVAC of this whole building, monitor temperature, how many lights are on and which rooms, etc. All of that you want to know at what time, what's the status. Sometimes we do it like in real time. It's called real-time monitoring. Sometimes we look at it in a historical basis. So either way, there is a lot of different type of time series analysis. Other common examples of time series analysis are healthcare data. So I'm sure a lot of you wear the smartwatches. It monitors, your vitals, and that's critical. Like you want to know what time was my heart rate, peaked, or if it has a EEG sensor, like you want to know other metrics or blood pressure, etc. Right? So and then. This can go at a different granularity of time. For example, if you're trading stocks, you want to know at this point in time, this nanosecond, what was the value of the stock? So you want to execute the trade, maybe like algorithmically, right? So it's essential then you have that information at that level and you can operate on it. And similarly, so this is another example of, real-time monitoring, like in a hospital bed. You're looking at, various biometrics. All of these data, the critical element again is the time axis, and we're noticing what is happening at this particular time. So time series data is really, if we look at it, it's everywhere because there is an element of time associated with most type of data, but there are certain data where time is more critical of an attribute. So I like to give examples of like DevOps. DevOps is very popular, like, right, observability, or ML ops. You're collecting various metrics, various data from, various programs or the model that is being trained or the model is deployed. What are the various metrics associated with that, from accuracy, confidence score, et cetera, or DevOps metrics that we are familiar with. IoT metrics, IoT data is big. All of the smart cars running around, selfless driving. I've heard there are few around in London as well now. But all of those, they are autonomous. And the way they are doing all of that is basically real-time machine learning. Various sensors collecting various type of data, various different models doing various things so that you're safely navigating from point A to point B. Robotics, and then industrial warehouses as well, where factories are automated these days. They have a bunch of sensors, robotic arms moving things around. You want to know in real time what is happening. So all of that data, like there are a couple of things about this type of data. One, that data can add up. It can, because that data comes in like in stream, so technically speaking, something like Kafka data, like in IoT world, it comes around like using different protocols like MQTT from different sensors or Modbus, low-level protocols. But the point is, it's a lot of data that's generated continuously. And if you want to store that data, as it's, everything costs. Storage, you have to pay for it. So the way most time series databases work, or at least the really good ones, they compress that data because you want to save on storage. So the data needs to be compressed. There's another thing called cardinality in the data, so which means like various attributes about the data or the metadata. Like this light is in this room. Is it on or off the state? In this building, in this office, what's the name of the sensor, etc. All of the metadata about that one particular series of data. That can explode because light can turn on and off, different time of the day, various attributes. So when you add up, it can have a high, like we call cardinality. Really good time series database will be able to handle that. All of that is important because first you want to collect the data, you want to store it somewhere, and then you want to train your machine learning model, right? You want to do various queries on the data as well. So especially on real-time monitoring, that needs to happen really fast because imagine if you are monitoring a factory floor, equipment, machinery, or hospital IoT sensors, you want to know in real time or almost near real time what is the status, right, of the patient healthcare, of the machinery, of the robot moving around. We have customers that use us for like satellite launches in space. Aerospace is a big industry that uses time series database. So all the sensors, they want to know in real time, like the status of their machinery, the satellite in space, or when they're launching it, various metrics they collect. So because it's essential, so that technically comes down to query. What happened here? Oops. Is okay, it's back. It comes down to query. You want to query, get that information quickly from the data, and then do some kind of action on it, right? If need be. So it's real-time analytics. Just want to give a little lay of the land because a lot of people say, okay, that's great, but I can just put that in Postgres or MySQL, right? Because it's a database. I can write to it. I can put a column with a timestamp, and there it is. But I like to show this slide to show the evolution of databases. PyData conference, I'm sure you're very familiar with that, so I'll brush through quickly. The birth of databases, we can put it to like relational databases. Postgres, Oracle, the giants, MySQL, right? They're good for many things, like storing information about this conference. How many people came? What are the sessions? How many people went to which session? What are the talks? Relational data, you can put that in the relational database. Unstructured data, best stored in, not a relational, like, industry evolved. There came something like MongoDB or DynamoDB, all these databases where you can store information that's NoSQL, unstructured. Another type of database, because people start realizing we need specialized technology, specialized database, search database like Elasticsearch. I want to have a really good search on my website or my e-commerce page because people are shopping and I want to make it quick. I want to have a really efficient search. Search database popped up. Then similarly, there was a need for time series specialized database. They have been there, but this is the company I work at. It's open source, MIT, Apache licensed database. Also, you can run it on the cloud, run it locally on a Raspberry Pi. We're going to run it on our laptops today. InfluxDB, it's a leader in time series database. Just a company plug. We have different types of offering. Like I mentioned, it's open source at the core. That's what our founders built it on, and that's what we really value. Around it, on top of the core of our open source offering, we have an enterprise database, and then you can also run it serverless, like on the cloud. On different cloud, you can host the cloud yourself, like deploy it on Kubernetes in a cluster. Various ways to run it because people need it for different reasons. A lot of IoT, they want to run it locally. They don't want to send it to the cloud. A lot of people have massive scale, so they want to deploy it in different architecture. How does all this work? So we're going to talk about this, and we're gonna imagine, we're going to talk about weather data, but really in production, I don't think many people working in weather industry, you're either getting data from some kind of like metrics, right? Could be DevOps metrics. You want to plan, you want to forecast like usage of various resources. You want to forecast that, or security is another use case. You are monitoring various events and metrics like, and you want to know. You want to detect threats before they happen, like some kind of a cyber attack, or that would be like an anomaly that you want to detect. So point being, there would be a data source where all this data is coming from. So generally, it can be from various applications, metrics. There's a place where you want to collect the data. You don't want to operate on the raw data. Generally, you want to collect it and store it because you want to have a persistence of the data. Sometimes you just want to show it, but mostly you want to collect it. So there is a way to collect data. We also have an open source tool called Telegraph, which a lot of people use. But you want to put that in a database that is optimized for that type of data, time series data. And finally, then you want to do some kind of like, machine learning job on it. Maybe you want to put it in a data lake, like Databricks, Snowflake, you want to do, train a model there, or you want to do it in real-time data as it's coming in, real-time machine learning. So, couple of terminology, I was mentioning it. Sure, if you're familiar with time series, this is 101 stuff, but just for those who are not, metrics are the boring stuff. Like if you're collecting, observability, DevOps data, like, okay, like how much RAM, is being used, and you can collect that every second or whatever interval. Events would be something interesting that happens to the metric. So there is a spike. Why did the RAM usage went up to 90%? What happened here? You can set up alerts based on that, etc. So fictitious example of, imagine you are working at somebody hired you at a big IoT robotics company. They have machinery that does various packaging, and they have an issue with one of the machine that is entering a failing state, and the data scientist needs to figure out what is going on, or the data engineer. The person who manages the plant, they say, machine enters a failing state, and which requires a manual reset by an engineer, takes a lot of time. We want to make this more efficient. Somebody has to go down, operate it, takes time, money, etc. Things go down. Nobody likes that. So how can somebody like you help with this? Think about it. There are various ways to do this. Big hint is today we're going to use like machine learning approach. There are other non-machine learning based approaches as well that we can use. So you can, first you want to look at the data. You want to inspect the data, right? And the easy way to do that is plot it up using a favorite plotting library. Have a look at the data, see where the, what looks irregular. So we can notice that using just plain old data visualization, simple statistical analysis, right? But oftentimes, it's not that easy to notice like a big spike and to be able to point the finger, was the source of the problem. So the data generally kind of maybe look like this. Hard to know what the real cause is. So for that, that's where time series-based machine learning comes in. Makes the job easier. These days, everybody like to throw everything at a big transformer deep learning model, like call ChatGPT and get. But we're going to talk about like how to do this with machine learning, because we don't need to just throw a big deep learning model. A lot of times it's not efficient. Couple of things. So what we were looking at is like called an anomaly, and an anomaly can be of different types when we look at it really. So there are contextual anomaly, point anomaly, collective anomaly. So for example, let's say if there is like a bot attack to your website, if somebody requests a page for, like it happened for like 3 hours, that's definitely an anomaly. It would be in a different, in a context, because you would look at, oh, okay, this thing, this web page, this is what's being requested a lot. This is the request that's being made, this IP address. You're gonna connect different anomalies to be able to decide, oh, this was the context. Or sometimes it's just the one, you only have one type of data, and then you're looking at the point anomaly or collective anomaly over a period of time. So a lot of this can be done in real time or non-real time on historical basis. I'm going to brush through this a little bit because this is going to take us a little bit away. So in InfluxDB, there is a thing called processing engine. It's a Python VM inside the time series database. We're going to do the anomaly, we're going to do the time series forecasting using that. It's all on Python. You can run it yourself, but we're going to run it within the database because it comes free with the database. Database is open source. And I'll talk about this when I do the workshop, because you can execute different jobs on the database, basically. Let's do this. Let's go. There is so now I hope you have your laptops open, and I will take you to the, if you open this web page, we're gonna follow these steps, and I'll follow with you. And I was editing till last minute, so there might be something, but together we'll figure it out. If there is something, if something goes wrong, do a live hands-on workshop. So what I would like is, I will make this bigger. Oops, sorry. That doesn't help. Where is it? It's somewhere here. There it is. Change it to that. There it is. There it is. There it is. Cool. Always authenticate. Security, huh? Okay, so if you just search weather forecasting, or you go to github.com, let me see how I can make this bigger. Oops. github.com/influxcommunity weather forecasting is the repository. But let me actually walk you through the slide, because I think that would help to get the idea of what we're doing. I'll just explain it here. If I need to show a slide, I'll show the slides. So it's a lot of people. If you have a question, I will answer it. Just raise your hand. But sometimes that can, kind of derail us from the workshop moving forward, try to see if you can ask help with your neighbor if they're a step ahead of you, if they're able to figure it out. Let's all like help each other learn this thing, and then of course use your favorite Gen AI program, use your favorite IDE. I still like Visual Studio Code, so I'll use that. But ask away, ask anything, raise your hand, because other people might have the same question. Before you move forward, what we're going to do is we're going to, if you have your laptops open, first we're going to install the database. And then we're going to grab the weather data. We're going to get the weather data from this website called OpenMateo. It has a free weather API, and it tells you all kind of information about weather. So we can get the data. Like I already have downloaded. It's on GitHub, by the way. But if you want to get it, you have to give it certain things, but it makes it really easy. So you provided the lat long of the geo coordinates of the whatever location. I picked London. That's what Google gave me, London's lat long. I got it for the whole year of 2024. So that's what, I put it in here. And I selected just two variables, temperature and precipitation. It rains a lot in London, so that affects the weather. And of course, temperature, that's our primary feature. So you select those two. And then I also selected the time zone, but we can change this using code. And then you want to download the CSV. So you can download the CSV. However, if you are doing it like that, then you would have to do a little bit data wrangling. You would have to change the format of the data a little bit. If you don't want to do that, the data is here. It's here in a file called london_weather_ns.lp. Basically, it's a modified version of the CSV. It's in a format called line protocol format, which is the format. It's open format. It's a format that a lot of time series database really like. InfluxDB created this format, and it has adopted industry-wide. And that's where we are putting the data. So all we are putting is, well, the first one is the table name, what the table will be called. And then we just have two columns. We have the temperature and the precipitation, and then another column, which is our timestamp, most essential bit. And the data it gave us is 1 year data on hourly basis, telling you the temperature, right? Just like you would see in a weather app. Hourly, it tells you, you see it in a nice graph, what's the temperature going to be today when you ask your weather app. So that's the data that we have. Now here, we're going to build a demo on this, but I just want to make a point that here is where, if you were to do this for your, whatever purpose, let's say somebody said, never do this example. It's like in data science, it's considered a taboo, like predicting stocks. So you can do the same thing. You can get, historical data of your favorite company, whatever favorite, get the, stock data and whatever information about it. I'm not a finance person. I'm sure a lot of people here are. And this is a much more simpler way to do the forecasting. Stock forecasting, even real weather forecasting, it's way too complicated. Even they cannot really predict, either of those things. So, but there are a lot of notebooks on Kaggle that have that thing. I had the idea of doing that, but then I said, no, I'm not going to do that because I didn't want to give anybody a wrong idea of, that we're going to learn predicting stocks and trade and everybody become billionaire tomorrow. So it's not, but just want to say that is also something very popular use case. So we'll go back here. So if you are on this page, can I get a hand if you're not on this page? I guess everybody, if you're not here, so one person, are you able to go on this GitHub page? Sorry, yes, it's just search for this one, Influx Community Weather Forecasting. it will take you here. And once you're here, first step is we're going to install the database. Really easy to install. It will grab it using a curl command, and it will install it. So I will open my terminal window right here, and I will paste it. So please do the same thing. Just run this command, and once you run it, it will prompt you with something like this. It would say, how do you want to install it? You can choose, you can install it as using Docker. If you have Docker, you should have Docker for that already in your system. It will download the Docker image, start it up as a Docker. But for right now, I would recommend doing the simple install. After the workshop, you can delete it. It's very small. The database footprint is very small. So, and we're playing with small test data. It's all going to be in one folder. You can delete it. You'll be if you don't want to keep it like that. But yeah. So I would choose number 2, which is the simple download. All it does, it makes a directory by this name where the database lives, the hidden directory. It fetches the shell script. That shell script would run the installer. And it will run the installer for your machine. Here it's going to run it for the Mac. It's going to say, do you want to start it up? We can start it, but I would say, I'll show you. So if you just hit Y, it asks you a few things. So we need to provide it a node ID. So we can go with the default one. The type of, so it's gonna store the data. It's asking, do you want to store the data in memory? Because you can keep the data in memory. That's if that's a real fast way to query the data because it's really fast. Second way is object storage. So InfluxDB, our new database version 3, the default these are the options, but it uses object store as the backend. So you can use local object store, or you can point it to an Amazon S3 bucket or Azure object store or whatever favorite cloud provider object store, or you can store it as a file. For easy demo, I'll just store it as a file. And the file format it stores, we use a Parquet file format. That's how we store the data in. So it's a very popular open source format. Any questions anybody has so far? So you do that, and it says this is the location. I go with that. Yes, this is where the folder size will become big, not too big, but just today we're not even streaming data. We're just putting the CSV, so it's just kilobytes. And then something went wrong here. So that should not happen. I don't have so I have multiple installations of this and some things like that. So you should not get that error if you're installing it fresh. What I need to do is I need to provide, it has already downloaded it. It has set up a path for me to run the command InfluxDB3, which is the CLI. It's in my path. And this is all it does. This is the step where it didn't have the plugin directory. So here, I'm providing it plugin directory. So you need to create a plugin directory. We'll come to that step, but let me just show you. Now it starts it up. And now the database is up and running, and all we're saying is just logs, info, right? So what we did is basically, make this bigger. So you should have downloaded the database. If it says start now, just hit N, or if you start it, then you have to stop it. Next thing, what we're going to do is we're going to set up a plugin directory. Plugin is basically, remember I said in the database, we have a Python environment. So we provide a Python virtual machine inside InfluxDB. Within that, you can run plugin. Plugin is a Python script that you can execute. And because it's Python, we can bring in any Python library. So we're going to use a popular library called Neural Prophet. It's a machine learning library, deep learning built on top of PyTorch. It's a modification of a famous time series prediction library called Prophet. And I'll just show you the web page. This is the one. This is maintained actively by Stanford University. It's built on top of this one, which was created by Facebook a few years ago. So it's a little bit dated now, and it lacks some things, which Neural Prophet fills those gaps. It's Neural Prophet is built on top of PyTorch, brings a lot of benefits just based on that. It brings the whole deep learning world of deep learning. So this is another library that is very popular, but I like this one. It's more actively maintained. So we're going to use that. But before we do that, where we're going to run is this diagram. So here, what I'm showing is at the top, the box is where the data is going to come to the database. We're going to dump the data we can do it as a CSV, but we're going to use as a line protocol file. You can stream the data right to it, MQTT, Kafka, whatever, or you can use our SDK and your application, whatever data is being generated, and you can write to the database. Then we're gonna, the processing engine, it has certain triggers. Triggers are basically when you want to run that Python script. You can do that as the data is coming in on write. You can do that at a given schedule, like on an interval, like run it as a cron job, or you can run it when a web request is made, like from a third-party website over HTTP. So we're gonna use one of those triggers to run this script. We're gonna just run it every minute. Why not? You can run it every second. We're just gonna predict the weather. Ideally, you won't be doing that, but for demo, we want to run it every minute so we can quickly see. It runs the Python code that will rely on the machine learning library. It's gonna do the forecasting, and it's gonna write the forecasted data back into another table. And then it's gonna create a plot, and then we can visually see. And then there are other fancy things you can do, add cache and stuff, so it's really fast, etc. So the second step, if you've installed it, just make a directory in your home or anywhere and give it any name you can give it. I gave it the name InfluxDB3-plugins. So we're gonna copy this and clear this. So I guess I already have this. So, but first of all, I want to make sure the database is up and running without any problem. And that's good. And the reason is I already have this directory. So you should create this directory if you don't already have it and put it anywhere. But remember, you need to start your database one more time. So, and then you want to run it by providing this command, influxdb3 serve, and then you provided the 4 arguments. Why is it quitting? That's so if you already have the database running, you can do, if you want to stop the database, because by default it runs as a daemon, it runs in the background. You can do something like this. It will tell you where is the database running. Oh, it's running here. And you can, this process, you can kill that process. Okay? Just if it is giving you trouble. Because when you install it by default, it asks you to start it. Don't start it because it starts it without giving the plugin, because it can run without the plugin thing. It just has a plain old time series database. But we want to use the plugin. We want to do machine learning. So we have to restart it, provided the plugin directory. I hope I'm not confusing. Who's able to run it with the plugin directory? Okay. Who's not able to run it? Anybody lost? Yes. Great. So if you want to stop it, it's way at the bottom on the GitHub, but all you do is run a command like this. If you are on a Mac, I guess it should work on any kind of Unix environment. If you run this command, it will tell you the first one, basically, that's the process. So you can kill it. Ideally, we should have a stop command, but this is like a hardcore way of doing it. It's more fun, so let's just do it like that. Or it should be this one. So yeah, that will stop it. And next time you look through it, it should not have it. This is just the one that it's calling right now. But it shouldn't have the database up and running. Here you can see the database is stopped now. It's no more running. So, but you can have multiple instances of running as well. But yeah, so run this command. This is here. How to stop, disable and stop. Do this, or if you like, you can do on a Mac. You can go here. You can search InfluxDB. It will pop up, and click that, and then hit X. That will stop it. Sorry, I should have been more clear, but if you were able to stop it, this is how we properly run it. We go back up here. We copy this code. We are now in setup step 2.1, and we want to run with the plugin directory, but make sure you create a folder. Whatever name you give it, you should use the same name. So here we're going to copy it, and we're going to paste it, and I will just change a few things here, but you should not have to, but you can if you want to. These are just locations and random name that I'm assigning it. But the main thing is that would be the directory where it'll store the data. We're going to store it as a file, Parquet file, and we have a plugin directory where the database will find the Python script and will run the Python script, okay? So you run that, it will start it again, and we can see the logs here. And then you open another terminal window. Let's keep that tab just running the database. You open another terminal window, and then we're going to run another command. Now, we're going to create a token because any type of operation we want to do with the database, we need a token. So we are on step 3. So please copy that. And as you paste it, it should be this command, InfluxDB3 create token. We're creating an admin token. Because, you know, we don't want anybody to like do any kind of like delete our data, right? Or any kind of operation. So we're going to do it securely using a token. And once you run it, it generates a token. And this is your token. And one thing you can do is you can export it as an environment variable. You can store it if you're on the window. There is a way to do that. Mac, Linux is really easy. I recommend doing that because then we don't have to type it, because we're going to have to pass in the token for all the commands we're going to run. So we can do something like this, All I'm doing is I'm saying export. I gave it a name. This is the name you want to give it. InfluxDB3 all in uppercase _auth _token, and I provided the value, and I hit enter, and I can check echo influx dollar, yes, dollar influx db3 _auth _token. Good. So that means it's stored locally in an environment variable. You can create a file, .env. You can open your bash. However you create your environment variables. Good idea to store it, because then you don't have to pass the token around. Otherwise, I'll show you. If you don't do this, you just have to provide the token every command. Okay. So once we have this, we're going to create our database. So to create our database is really easy. We're on step 4 now. Okay. So we're going to create the database give it any name. We can call it my awesome DB or my weather database, anything, and we don't have to provide the token argument. We just provide it. It says database created. Amazing. And then we're gonna say show us the databases. So we're gonna look at it. By the way, all of this you can do through UI. We have a UI tool as well that you need to download separately. It's much easier, quicker to do it in the CLI for the workshop purpose. So I'm doing it here. But we have a GUI where you can see everything, the schema, run the queries. It even has a natural language support. I'll show you in the end where that is. But for this purpose, we're going to run a bunch of copy paste these commands. Much easier. We're going to get through hopefully in time. So here it's showing us, okay, amazing. We have a database. We have two databases actually, because we also expose the internal database, the internal schema, which is the underscore internal database that comes with us. And we created our new database. Awesome. Now, if you're here, you're done with step 4. Now is the time we're going to grab the data, the weather data, okay? So you should have this. In case you didn't create environment variable, I just want to show you. If you run a command like this, remember in this step, don't lose this. When you create the token, save it at least in a text file locally or somewhere, or open a new tab. Open a new tab, oops. Open a new tab, and here, run this show databases. And if you run this, it will say error not authorized because we didn't provide the token. And here we just pass in the token. So all I did, I ran the same thing, but at the end I provided it -- token and in quotation the actual token string, and then it allowed me to do the operation. Yeah. So so if you easy way is you create an environment variable like this, export. Then you don't have to do that every time. But if you don't do it, just have to provide -- token and in quotes put the token. Okay. So hope we're good. Any questions? Okay, let's get the data now. So we're gonna grab the data, and we can grab the data. Like if you go to this website, open Mateo, or just go to weather data free API. That's what I did. And this website, first one that pops up, free weather API without using credit card or anything like that. And then because we can, you're just trying it out. Try the API, and it brings you to this page. But we want to get the historical data. So this is going to, so for historical data, they have a different one. It's on the left side, historical weather. And here, if you type in your favorite city, London, geo coordinates, it'll tell you these are the ones. And you can type your home address, but for this purpose, doesn't matter. And then we're collecting the 1-year data, 2 values, temperature, precipitation, and then you say, okay, download this. It's going to download as a CSV that we can open. And the top one is the metadata. So we can ignore that. It's just telling you information about the CSV. Essentially, there are 3 columns here. So we have historical data from the starting of 2024, 1st of January, on every hour. And we have the temperature data and the precipitation, rain, snow, etc. Right? So all of the data is right here. Now, we can write this data, but we have to change a few things to write CSV directly. What I would recommend doing is opening up ChatGPT, your favorite tool, because influx data, line protocol, influx data. There is in influx data and many other time series database, the way they like to save data, because it's a column-based database, it's a columnar database, not like a traditional row-based relational database. It's column, because one of the column timestamp is index, is optimized for that. So the schema is slightly different. So this is how it's a comma separated, similar to CSV. The first one is your measurement, or we call it table. It's the name of your table. So you don't have to create a table. The minute you dump this data, database will create a table, populate the data. And then we have a key value pairs. So here we have location. We have, this is like the metadata about it, the actual data, we call it the field, and then the timestamp. Timestamp is also, if you don't provide a timestamp, you write a line protocol, the database automatically puts a timestamp every time data is written, right? So what we are doing, we're converting this to line protocol data. Easy way, if you don't want to do all that, I have it here. It's the one I downloaded, I converted it into line protocol. It's here. And all we're going to do now is we're going to write this command, number 5, InfluxDB3 write name of my database. We're going to write a file where the file is this one. And then we're going to provide it the token. You don't have to provide it if you created an environment variable. Okay? So I'm on step 5. I hope everybody's there. We're going to go here. We're going to go here, and we can provide your string, or if you created environment variable, you already know not to provide that, okay? And I already have this file. No such file because it's not in this location. My file is saved in the, so you have to provide, if you download it locally, whatever location your file is in, you have to provide that location. So my file is InfluxDB. It's basically, it's here. I downloaded it. My plugin, this is my plugin folder. This is where my Python code is. And I downloaded the file in the same directory. You can download it any directory. Just make sure to provide it the absolute path for that, or if you are in that folder, the relative path. Okay, just provided that path for that InfluxDB3 plugin and London weather, something like that, and it will say success. So meaning it wrote the data in the database. I hope you're there. So now we can, just to confirm, because every time you want to do any kind of database operation, it's good to confirm. We're gonna inspect that. We're gonna quickly look in the database. So I'm gonna copy paste. I'm on step number 6. I'm gonna copy paste and run this thing. And here, this time I'm going to run a different command called InfluxDB3 query. This is how we can query really quickly. All we are doing is writing simple SQL saying show me all the tables in this database. And here we can see the table that just got created, London weather. Basically, I already had it. Actually, I didn't have it because this is a new database, so I just recreated it. But even if you had it, it would rewrite the data. So it's here now, and now we can query this. So again, here we will delete the token thing. That's not required. If you don't have it, you will need it. And I'm going to run another simple SQL query. I just want to look at everything in this table that we just created, London weather table. Show me everything that's there. And here it is in the database, all of the same CSV data for the last year, right? That we saw precipitation and the weather and the temperature. Okay, now let's install the machine learning libraries and then let's run the Python program. Okay, so now if you were writing this, so you could have done this thing. You can set up a different Python like environment and install using pip, or you can set up a Python server, your favorite server, and then run this thing. But we're gonna run the Python script within the database. So if you have created this folder, you can you can create a file, but before you create a file, let's install the packages. So we're gonna install a few different packages. Instead of pip, because we already have a Python environment, we use the InfluxDB3 command line, our command utility. And we call install space package and package name. Same thing, you would put it in using pip. So I'm installing pandas, neural prophet, 2 different plotting libraries. And it does the installation, great. Now, I hope you are at this step. If not, I hope you're following what I'm doing, but I really would like you to try it on your machine. If you have any questions, ask away.
Is there any way to do a verbose installation? Because I keep getting stuck and I don't know what the issue is. I just don't have any output. It's been running for a while. Is there any, like a verbose output or something, so I can get the logs, see what's wrong?
Yep, all the logs, if you have the database running in the foreground, it'll be here. Okay. It'll be here. It'll be here. Yeah, it will be here.
I just canceled it a couple of times. Yeah.
I have to create a new console, Bash terminal, and do it at the same problem.
You have the same problem.
So just open a new Bash terminal.
Okay.
And try it.
Fair enough.
It might take a little bit because it is downloading a lot of different big libraries. Few seconds. So, okay, we're moving on to the next step. So, because there are a few slides and things I want to cover after this as well. So, we're gonna copy the code. Well, first we're gonna let's create a file. Let's call it forecastlondonweather.py. The file is right here. It's this one. And you can copy paste this file, or you can download it and download this file, move it inside the plugin folder, okay? Or you can copy paste it and just call it London. I already have this code, London, forecast London weather. So it's here. It's here. So if you go open your favorite editor, just easy way is to download the file and then move it here. Move it here. It's already there for me, so I'll keep it. It's this file, and I'll go through the code. What's happening here? So basically, we're gonna, so when we create a Python plugin inside our database, we have to use this API, process schedule call, and inside of this function, because this is the function that is going to be called by the database when it's gonna execute the script. And all our operation, we do it inside of this. So it's gonna it gets the instance of the local database that it's running, and we provided an argument how often we want to run the script. So remember I talked to you about you can run the script at a schedule, like a cron job, every second, every 30 seconds, every day, every month, whatever frequency you like. So you provide that argument here. It gets a copy, the instance of the database is running, and you can provide it any other argument as well. I don't have anything else. And here, first, we're gonna query the data, and that's written in our database, and we're gonna store that as a pandas data frame object. And we're gonna train, we have 2 features. So we're gonna do, we have the precipitation data and we have the temperature data. So we're gonna set up, you can set up whatever time frame. For this case, I'm training 3 months of data, and we're gonna predict 7 days of data. Okay, so we're gonna do forecasting on the 7 days of data. So, so here we provide that, and how the library likes it in hours. And then our columns. So we rename the column to DS and Y. This is our time stamp basically column from the database. And it's Y-axis in terms of neural profit library. And here we're gonna pass in few arguments. We want because the data has seasonality, right? It's so in time series data, the data can have various attributes. Seasonality is very common. Like for example, like weather is obvious, right? It fluctuates with season. If you have sales data, you're forecasting. Let's say you have a shop, big grocery store. You wanna know what to stock for the next month at your grocery store, and you know that in different seasons people buy different things. So this is how the neural network handles seasonality, but we have to provide seasonality because there is seasonality in our data. The library handles it. Underneath, it uses Fourier transformation to handle seasonality because it smoothens the data. It's not linearly chopped up. So we have weekly, daily seasonality. Weather changes every day, right? So we provided the learning rate, give it a batch size, and this is where we do the training for our data frame object called model.fit. And here we're gonna do the forecasting, and the data that we're gonna get back, the forecasted result data, we're going to write that back in another table where we're gonna have our forecast, just so we can look at it neatly in a different table. And this is the way where we can create the line builder, basically the line protocol format that we use to write data back into InfluxDB. So we get the right access, etc., and then we save that data. Then we also call a plotting library, matplotlib, to plot it so we can visually see it. And here's an interesting thing to note. We're doing multivariate time series forecasting. So we have two features. The key feature is temperature, but temperature in itself, it will give you a forecast, but to get a more accurate forecast, you want to know other factors that are associated with the temperature. Like rain is a pretty big one, right? If you just know yesterday was 10, day before was 12, you can get a prediction, may not be that accurate, right? But the richer your data set is, that's why we also got precipitation. You can get other kind of data at more granular level, but we have two variables, two feature vectors. So we're doing multivariate. We can train two at the same time. Instead of training one using like just temperature, we're using both the objects to train the model. So that's another benefit of neural profit over other statistical techniques. Well, some of them they do support. So I'll go in this slide. There are other ways to do this using LSTM, using statistical analysis like ARIMA. That's another way to do time series forecasting, prediction, anomaly detection. But the latest way is using deep learning. This library is very popular. Now there are more transformer-based libraries using large language models. One is called Time LLM. There is one by Amazon Research, which are designed because LLM's transformer, it's trained on all kind of data scraped from the internet. It doesn't have generally good time series data. It's proprietary data in many ways. But now there have been active research where they have collected and they have trained like transformer models based on time series data, and then they have added an LLM so you can talk to it in natural language. So those also exist, but we couldn't run that on our laptop, do it. We have to deploy it on Google like a cloud notebook or something like that. So it's much easier to do this. And the accuracy, it's not that bad. Like everybody, when they publish a new research, they say ours is the most accurate, beats others. I'll show you those slides as well. But this is pretty good. It's state of the art is now moving to more deep learning based models, even for time series data. So if we have this code, now the way to run this thing, so we can directly run the Python program. We can, but we have to then create we have to use directly the Python. We have to call, the virtual environment, invoke the Python interpreter to run it. But we want to run it like at an interval, right? Automatically. Imagine, again, you can run this on a streaming data. You can predict like for the next, like data came in, like I guess weather data is not that essential to predict like what's going to happen next second, next minute. But if you have sensor data, IoT, stock market data that you can write, and you can do real-time ML, real-time forecasting. So here we go back to the thing. We go back to our README, and what we need to do is we will create a trigger. A trigger is basically what it says. It's a trigger that will trigger the script. The trigger is for the database to know when to call the script. So we go back here, we clear this out, and we copy paste this, delete this line. We say we can specify trigger every minute. This is the argument that we then read in the Python script, and then we do whatever we need to do. So right now we're running it every minute, and we provided the name of the plugin or the Python program. This is what I named it. You provide the name of the database, and you can give it any name. London weather forecast PyData, whatever. Just remember this is the name that of your trigger, because later on you can delete the triggers. This is the name it gets. So trigger created, awesome. Now, if we wait a minute, so everything, by the way, gets logged here. Here, if you read the log, it says success, this, that, what's going on, we did a query. This is the log of the database. So we can read the log, but if it's 12:18, we can come back in a minute. But until then, we can run query. I'll just bring it back from here much quicker. We can do this one. Show tables. So we can run show tables query to see what. Oops, that's not good. The database stopped for some reason. No problem. We're just going to do this again. Conflict. Oh, I need to create token. Wait. What is going on here? Oh, okay. So something weird is going on in my machine. Oh, yeah. So you're right. You are right. So let's see. Oops. So if I comment out the code, sorry, I apologize. Let's see. I have the one where I called a different plotting library. Essentially, there is a plotting library that you want to plot. You want to run that separately. So the matplotlib. So essentially, we want to remove the matplotlib code from it. It's crashing the Python engine, and all we want to do is we want to write the forecasted data into another table, and then we can write another script that can do the plotting, and we can send that. So the way I was trying to do this was we have another script that makes a HTTP request, and you can return it HTML, JSON, image. So that is the request trigger. So that's how you want to do it. Then you want to call that, and then you can return a web page that can show the data, the plot. So we only have 8 minutes left. Let's see. Has somebody been able to run it and see the data? Only one person, 2 people. If you don't mind putting a little GitHub gist or something, yeah, just do a perfect PR, and then we're gonna copy so everybody can at least have that on GitHub. Just put the PR, just put this is the correct code. We'll copy that, we'll run that. And then we can create another separate one. I'll create it. I'll fix it up this afternoon, and then you can see in the plot as well. And you should be able to see the line graph with the forecasted data and comparing with the actual data. Because remember, this data that we're training it on, it's the data from 2024. We already have the data. We only trained it for the 3 months, and we predicted the 7-day data. So that's always a good thing to compare the actual data versus the forecast data. And then we can see if we need to tune any hyperparameter, where, if there is a big discrepancy, how, where was the problem in our training data, essentially. So if we have this here, somebody was kindly able to, the whole README is here. Okay, amazing. Well, there's something else. I appreciate these. Let me. The problem is my database, because everything I had it, but everything is gone now because my database got killed. So all this, yeah. Let's go. I'm going to go back to slide because I want to cover a few things, important bits. We're going to go here. This is what I was talking about. So when we look at the data, if the plotting actually worked, would see something like this. Not the extra annotation on top of that, but we see the graph, and here we can see the seasonality, basically the seasonal variation of the data. And there are various ways to do this. So there are more statistical approaches to do this. Rolling averages, very popular library called ARIMA. And when we first training the data, there are a lot of things in the data. Often the data has holes. Data is not clean. You want to clean the data. You want to make sure the data it has every information. Generally, there are gaps. Sparse data is a big problem. So you want to fill that in. There are various ways to do that. You can calculate the mean value, and you can write that, etc. So, and then also what level of precision is the data? The cardinality, how many features? Like right now, we're just looking at temperature and precipitation that you're training. All of those we need to consider. So there are a few other approaches, more statistical classical methods to do this. Exponential smoothing using lagging features. ARIMA I talked about. Using moving averages, very popular in finance. There is for the library ARIMA to handle seasonality. There is SARIMA, but like I was mentioning, now everything is going towards deep learning. So there has been explosion. All of these are new, latest libraries. This is very popular. Time LLM. There are some other ones that are popular. There is one by AWS research, which is one of them here. But the point being, there are many ways to do forecasting. There are many libraries. Everybody's going to say we're the best. But what you really want to look at is, for like any machine learning library, they're like the current, the state of art, like the accuracy of various libraries. So this is what I meant to touch upon. So today what we did is we did like batch machine learning. So we had historical data, we trained that, and we tried to create forecasting with that. And that is great, for historical data. But sometimes we need to do this in real time, for data that's coming in real time. That adds more. Everything becomes more complicated and more complex. But it's a solved problem. So it's called real-time machine learning using online prediction, and very common use case is fraud detection, right? So this is kind of how it works. When you use your credit card in some other country, when it gets blocked, it's using machine learning model that detects fraud, and it flags that as a fraudulent possible transaction. Just for precaution, they block it until you call and you figure out and say it's not fraud. And those models aren't perfect, because a lot of times we know this is not fraud. I have this, I'm traveling. So again, it's not a solved problem. In IoT, I don't know if anybody works in IoT here on robotics, manufacturing industry. I like to show this slide for forecasting purpose. So the most expensive way to fix something is when things are broken. Like we talked about in our fictitious use case, you have to send somebody in a physical plant, look at the problem. Next thing is, people do scheduled maintenance. This can be for hardware or software. Based on a schedule, you are looking at things, you're monitoring, you're taking action. Better way is preventative. You're proactively looking at operations, observability, and making sure things don't go wrong. Where the industry is moving is predictive, where you're already forecasting, predicting with accuracy. That's the big problem. Accurately, and before any of these problems even occur. So it removes at least definitely the bottom two layers. And that's with all of these libraries. The whole world of time series forecasting comes in. There are a few more libraries. This is the one we looked at today in orange. This is the one that is kind of like even more latest and greatest from Amazon Labs, Chronos. You can have a play with that, but it needs a more powerful GPU to run that. And lastly, I have a few blogs, and there is another GitHub project out, which and then there are some other libraries here, video tutorials where we go inside. You can learn about it. You can contact me for any questions. If you're interested in the database, you already have played with it now. If you have any questions, ask me. And with that, we've come to an end. But I do want to show you one thing really quickly. Series forecasting. My colleague wrote a blog post as well. I would link this in the slide as well. Oops, not this one. So she used a different library. Actually, I would. This is using Facebook, and it has similar example of time series forecasting, and it does like she does it for like a Wikipedia page, like web traffic, and she forecasts like web traffic for this footballer and his Wikipedia page, and it's 3 different steps here. You load the data, you forecast it, and you plot it. And that's what we did today. It's using a different library, Facebook Prophet. But I would link this as well, so you can also run this very easily. You've done all the hard work. All you need to do is download these 3 programs, plugins, put it in the folder, and they will load the data and then run it, and you can see that. So I will also load this, link this one up. And any questions? Thank you very much for bearing with all the hiccups today we ran into. Thank you.